Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, we are going to implement an end-to-end ETL batch data pipeline using Airflow, PySpark and AWS EMR. Okay, so without any further delay, let us go through the architecture first, and the architecture can be shown like this way. We are having three components: extract, transform and then load, or ingestion, then curating the data and then publishing the data, whatever you say. So as a first step, what we are going to do, we are going to download the dataset from internet using wget command, and we are going to upload the data in AWS S3. That can be considered as landing layer. Okay, right? So this activity, like downloading the data using wget command and uploading the data in landing layer in S3, one particular folder, that we will perform as one EMR step operation. Okay. Now from the landing layer, we will consume the data, and using PySpark, we will process, apply all the business logics and transformations needed, and then we will write that data in another S3 location, which is termed as curated layer or processed layer, right? So this transformation phase again we are going to implement using one EMR step. Okay. And as part of the load stage in the ETL pipeline, from the curated layer to a Snowflake external table, we will load the data. Basically, we need to execute alter external table refresh command, and that way in the Snowflake external table, which is pointing to that particular folder in the S3 bucket, which is termed as curated layer, the data will be loaded that way. Okay. Just we need to execute alter external table refresh command. So this is the overall pipeline. Now this pipeline just I am showing for POC purpose. You can extend the concept to implement any complex data pipeline with more number of EMR steps. Okay, right? So our Airflow flow will look like this, or Airflow DAG or directed acyclic graph will look like this. So first we are going to launch one EMR cluster, and then after processing we will terminate that EMR cluster. So basically, in short, we can say this is a transient EMR cluster operation, not a persistent EMR cluster. And transient EMR cluster has a lot of advantages over persistent cluster, which I already discussed in my previous video. I'll be sharing the link of those videos and blogs where I posted about transient cluster advantages. You can go through those. Okay. So here what we are doing as a first step in the DAG operation, we need to launch one EMR cluster, and then we will download the data from internet and upload in S3. That is called as ingestion layer. Right? Now this ingestion layer activity we will be doing as EMR step. So here, after creating the EMR cluster, here we will submit an EMR step in that newly created EMR, right? Now we will continuously poll the status of that EMR step, whether it is completed or not. Okay. If it is completed, we will go to transform layer, and then we will run our transformation logic as another EMR step. So here in this transform layer, we will submit that step, and as part of the next DAG operation, we will continuously poll whether that transform layer code execution is complete or not, or the EMR step is complete or not. If it is complete, both of the operations are done. We no longer need that EMR cluster. So we'll terminate that EMR cluster, and then from where Airflow is running, from there only we can execute alter external table refresh command. For the last step, we no longer need that EMR cluster, right? Using Airflow only, we can execute the Snowflake SQL query, which I already discussed previously, that how to connect Snowflake and Airflow. That concept we can use in the last step. Okay. So this is going to be the directed acyclic graph. Now, without any further delay, let us go through the codes. So here I will open my notepad, and here is my ingestion layer code. So it is a shell script. What we are doing, we are executing wget command to download the dataset from internet. So let me just show you the dataset once. So if I just hit this particular URL in internet, I will be getting IRIS data. And if I open that, here you will see that it is our popular IRIS dataset, which is having sepal length petal width as first 4 column, and the last column is class name. Okay, like that IRIS Setosa class is there, IRIS Versicolor class is there, and our last class is IRIS Virginica. Okay, right? Point to be noted, there is no header. So once we read the data in transformation layer, we need to add header also in the Spark level, right? So this is our data. That one we are going to upload using AWS S3 CP command. Okay, in a input folder in IRIS Seta bucket. Okay, and the file name in which this data will be loaded is helloworld.csv. So this is all about our ingestion layer. Very simple. All we are doing is using wget, we are downloading the data and uploading in S3. Now, as part of the next step, let us go through the PySpark code, which will read the data from this input folder and then process it and write in output folder. Okay. So this is our transformation code. It is again a very simple code. We are importing PySpark sessions, all other types, etc. And then here we are creating our Spark session. And here this is our main function, which will be executed or called when this Python code will run. Right? What we are doing? We are specifying here that particular location where our ingestion layer code has written the data. If you observe, our ingestion layer code has written the data in S3 ID setter and then input folder, right? Here also it is same, S3 ID setter and then input folder. From there, because there is CSV file, we are reading that data in CSV file format. Option, we are giving infer schema true, but we are not providing header true, because in our this particular file we have seen header itself is not there, right? And we are loading that data from that input folder. And here, if you observe our CSV file, we don't have any column names. So here we are using 2df method to add the column names, which are respectively sepal length, sepal width, petal length, petal width, and class name. If you have worked with ID's dataset, I hope you know pretty well that these are the column orders and these are the names. Now here I want to do a very simple operation. Basically, I want to get for different classes, that is Setosa, Versicolor and Virginica, how many count of records are there. So we are doing a group by operation on class name and we are calculating count. Okay. And that data we are partitioning into one single frame and then we are writing in Parquet file format. Although here a header true is not required for Parquet, so I can remove this one. And then mode will be overwrite mode. And we are saving this data in ID setter bucket only, where our input folder is sitting, but the folder name this time is output folder. So the landing layer data, where data is ingested, is termed as input folder, and then after processing it, we are writing in output folder. Okay, pretty much simple PySpark code, no complex operation we have implemented. You can basically here write as much complex operation as per your business need, not at all a problem. Okay, so this goes our this particular layer. Now we need to understand the Airflow code, which will do the whole activity. First, it will launch the EMR cluster, submit the ingestion layer step, then submit the transformation layer step, and then once both are processed, both are done, it will terminate that cluster and execute that alter refresh command. That Airflow code, let us go through that. Okay. So here, this is our Airflow code. We are doing all the necessary imports as usual. Now here we are defining the arguments and the original tag. So here this particular tag we need to refer while creating different tasks. Now here, if you observe in the whole activity, first we need to create EMR cluster and then submit this step, and we need to continuously check whether the EMR step is successful or not. So all this activity, to perform this, we need EMR client. So we are creating here client for our EMR. So client equal to boto3.client EMR. We are mentioning the region name, access key, secret key, and all these details. Okay. You can configure this as environmental variables, or other way also you can follow. I just directly hard coded because this is just a POC. Now here we have written the function for creating the EMR cluster. Now this one already I discussed in my previous video, where I discussed transient EMR cluster, that how to create EMR cluster. Okay. Basically in Boto3 client, if you have already created for EMR, you can just call run job flow method. Okay. Here the EMR cluster name, we are providing transient demo testing, and then master node configuration, slave node configurations we are providing. Now EC2 key name. So maybe if suppose in future you need to do a SSH in your EMR cluster, for that you need a key pair, right? So what is the EC2 key pair? That name we are providing. Make sure this particular key you have already created earlier beforehand. And then here keep job flow alive when no step. So in case of transient cluster, we generally keep this false. But here what we want, we are executing multiple steps. So once one step is completed, then and there I don't want to terminate the cluster, right? I will terminate the cluster programmatically using Python code. So that's why I have kept it true. So that what will happen, once one particular step is completed, then and there the cluster will not be terminated. Then it will give me opportunity to make a second step execution in the same EMR cluster, right? So that's why I have kept here keep job flow alive when no step true, and then termination protection I kept is false, not a problem. Now EC2 subnet ID. Whenever we launch EMR, we are launching in a subnet. So based on your AWS account, you can configure the subnet. Now here, where the EMR logs will be written, that particular bucket name I have provided. So this bucket also existing in my AWS account beforehand. Let me just show you. So this is the bucket. If I just copy and paste in bucket name, here see the bucket is already existing. So that S3 bucket name we have provided. Now EMR has multiple version. For what release we want to launch an EMR cluster, that one I am providing. I am using 5.33. Bootstrap actions not needed for my case. If you need, you can mention the shell script which you can upload in a S3 location, and that S3 path you can mention in Bootstrap action by following the dictionary format what is mentioned in the Bodo3 documentation. Okay. Now visible to all user true. Now these two roles which we generally use for launching EMR cluster, and then application. We need only PySpark, but I am launching Hive also, not a problem. And then here I am printing that the cluster is started with cluster ID blah blah and returning the cluster ID. Okay. So here in this cluster ID actually multiple things will be there. For example, lot more details, not only cluster ID. So here when you will refer this particular cluster ID in future, you need to make sure the job flow ID, that particular key you are extracting. So cluster ID will basically return you one particular dictionary. From there, the job flow ID is basically what is our EMR cluster ID that we need to extract. Okay. So that is basically our create EMR cluster. Now coming to next function, which is add step EMR. So here what we are doing, we are adding step to our EMR cluster what just now we launched. So for adding a step in EMR cluster, we need EMR cluster ID, the jar file, what will execute. Maybe suppose we want to execute a Spark submit, that time we can use command line jar. Suppose I want to execute some bash commands, that time I can use script runner jar file, right? So different jars are available, and the step argument. So these three inputs we have passed. Here I am printing those. This is totally optional, and using client, that is basically Bodo3 client for EMR, we are calling that method add job flow step, and using which we are submitting a step in it. Okay. The name also you can change for different step, but here I have hard coded. So that way for all the steps it will be having same name, but name also you can take as an argument and change it for different step. Okay, right? And here we are returning the step ID, because once we submit this step, next step what we need to do, we need to continuously poll that whether this step is completed or not. So along with EMR cluster ID, we need that step ID also. That way only properly I can poll that whether that step is completed or not, right? So here to poll, here I have written a function that is get status of step, where we need to pass cluster ID and step ID. So here using describe step method, we can check what is the state of our step function, what is submitted in the EMR cluster, which is having cluster ID equal to this one what we are passing. Okay, right? So once that is completed, then only we will move to next step, right? So here this is the function that will do that activity. Wait for step to complete. So here we are providing cluster ID and step ID, and we are running an infinite while loop. We are continuously checking the status of the step using get status of step using this particular function, and if it is completed, then we are breaking this loop, else we are having a sleep of 40 seconds, and then again we are polling. Okay, like that we will continuously poll until our EMR step is completed. Okay, right? You can handle the failure situations in a better way. Suppose the status is showing failed, then you can throw the exception and your Airflow job will fail in that particular task only. Those kind of optimization you can handle. This is just I am showing for POC purpose. So this particular function can fulfill our requirement as of now. Now another function we need, that is terminate the cluster. This we will call once both these steps are completed. So for that we need that cluster ID. So in Bodo3 client for EMR, we are calling the method terminate job flow, and here we are providing the cluster ID. Okay, that way the EMR cluster will be terminated. Now it comes for creating our original DAG. Okay, so with DAG, so this DAG is basically what we have already configured here, right? Now in this DAG we need to add different tasks. So first task what we are putting is create EMR cluster. So here see, it is basically a Python operator calling a Python function, and what is that function? Create EMR cluster. So this particular task will call this particular function, that is create EMR cluster, and it will create an EMR cluster for us, and it will return the cluster. Okay. Now, as part of the next step, we need to execute the ingestion layer code. That is, this particular shell script we need to execute, right? So how we will execute this? We need to execute this as a step command. So for that, what I will do, here if you observe, I have created a bucket id setter, and then here I have created a folder called scripts. So here I will upload all scripts. So here ingest.sh, that one I will upload. It is uploaded, and then here I need to upload the transform.sh also, transform.py. So both are uploaded. Okay, right? Now here what I am doing, in the second step, once the cluster is created, I am submitting my first step, which is doing that ingestion activity. So we need to execute a shell script. For executing shell script, we need to execute script runner jar file, right? So script runner jar file is provided by EMR only. Just you need to make sure you are mentioning the path properly. So this path is almost constant. Only you have to change the region name if you are using this particular code in some other region. Suppose you are executing in USS 2, just you need to change this to USS 2. That's all. Okay, no other change. Okay, right? So script runner jar is our jar file, and then what it will execute? It will execute ingest.sh, which is uploaded in id setter bucket in scripts folder. That's what its location, right? In id setter bucket in scripts folder, we are having ingest.sh. Now it is calling what? It is calling add step EMR. So add step EMR, if you observe, it needs 3 arguments. One is jar file, which is script runner jar we are using. Step argument. Step argument basically here is script runner jar will execute what script? What shell script? It will execute ingest.sh. So that's why we are mentioning here that s3:/ in id setter scripts ingest.sh. Okay. Now one more important argument what it need, and that is the first argument, that is the EMR cluster ID. So see here in the create EMR cluster, in that step we got the cluster ID. So that is stored in xcom variable. So from there I am extracting ti.xcom pull create EMR cluster. From there the job flow ID. So this will return a complete JSON. Complete JSON I don't need, only the job flow ID. So job flow ID part I am extracting, and then here I am using that as first argument. So this is cluster ID. Then we are mentioning script runner jar file, and then here third argument is actual bash command or shell script what will be executed. Okay, right? So this is our ingest layer code. Now coming to polling. So what we need to do in this step? In this step, we will continuously check whether this particular step is completed or not. Okay, right? So this is going to be again a Python operator, and here this is going to call wait for step to complete. That is basically this one, infinite while loop. Okay, it needs only 2 arguments. One is cluster ID, one is step ID. Cluster ID we can get from the xcom of create EMR cluster. That is from our first task. We can get the cluster ID. Now here in ingest layer, here this one add step EMR. If you observe this particular function add step EMR, it has returned that particular step ID, right? So that step ID I can get from the xcom of the second task. So that one only I am using here. If you observe the step ID I am passing as ti.xcom ingest layer. So from the ingest layer I am getting that particular step ID. That step ID I am passing as part of the second argument for our poll step. Okay, it will continuously poll whether our step is completed or not. Once it is completed, it will throw the code for transformation layer. Again, it is almost same. Add step EMR we are calling, EMR cluster ID we are passing, which is basically returned as part of our first task xcom. And then here, so now we are going to run a Spark code. So for running Spark code, we can use command line jar file. Again, this is provided by EMR. Now the only difference between script runner jar and command runner jar is script runner jar need that complete path and it execute the shell script, because our ingest layer code is a shell script. So I used script runner jar, but now this time it is a Spark code and command runner jar can do that activity. So I am using command runner jar and it don't need that complete S3 path. Okay, right? So I am using that way. Okay, now this is our transform layer code what we have submitted. Now again we need to continuously poll whether our transform layer code is successful or not, or step is successful or not. So for that again we need only 2 things, cluster ID and then the second is our step ID. Okay, right? Once this step is also successful, we need to terminate that cluster. For terminating cluster, only one thing we need, that is EMR cluster ID. So we are calling terminate cluster function with the EMR cluster ID as the function input. Okay, so this OP args will be taken as positional argument. So terminate cluster, if you observe this is a Python code. It need only cluster ID. That cluster ID, how we are passing? We are passing using this kind of XCOM in OP args. Okay, this will be taken in this terminate cluster function argument. Okay, right? Now once the cluster is terminated, last step is nothing but alter external table refresh command execution. Okay, that way from that curated S3 layer where this particular transformation has written the data, that is group wise count, right? That particular data will be loaded in ID's dataset table in Snowflake. That is an external table, so alter refresh command execution is sufficient. We need to make sure we have created the Snowflake con beforehand in the ER. That's all. Okay, and this is a very simple dependency. First create the EMR cluster, then execute the ingestion layer, then execute the poll step layer for this ingestion layer to continuously check whether this is completed or not. Then we are executing transformation layer. Then here it is polling whether the transformation layer is completed or not. Then here we are terminating the cluster. And finally, we are executing Snowflake load command from here. Okay, right? So this is our simple hello world.py, which is our Airflow code. Okay. Now here what we will do, we will save this code and then we will execute all these commands to launch our Airflow cluster. Okay. So here I will open an EC2 instance. I'll go to instance running, launch instance. Here I can give the name Airflow cluster. Okay, I can choose Ubuntu, free tier eligible. Here I am choosing the second one, but I need T2 small, which is not part of free tier. So little bit cost you will get while doing this POC, but make sure you are terminating all the resources once the experiment is done. Otherwise you might get unnecessary cost. So here I am launching that cluster. So here it is in pending state. Let it go to running state. Till then what we will do, we will change the security for this. We'll edit the inbound rule and we'll add the rule for all traffic as of now. Save the rule. I'll go to EMR dashboard. Here currently money. Here it is started. I'll copy the public IP. I'll go to putty, paste this. I will choose my key pair file. And the login as Ubuntu. I will make sure that timeout is not happening. The connection I will keep as 20 maybe. And this is done. Now I will quickly execute all these commands to launch Airflow cluster. So this step already I discussed in my previous video also. You can skip the installation part if you are already aware of this. But yeah, we have to do this anyway. In actual production system, when you are working in real world project, these things you will already get as setup environment. But while doing POC, we need to do this ourselves. Then install AWS CLI. We'll install Boto 3. We will install virtual environment. We will create a virtual environment env. We will activate that virtual environment. And then here now it's time to install Airflow. And then as part of the next step, we will install all the Snowflake dependencies. And then as part of the next step, we will execute Airflow DB init once. And then here we need to use Postgre as our Airflow backend. So here I am installing Postgre. If it is asking any prompt, do you want to continue, just give YY for everything, not a problem. And then here I can execute SQL command, and then here these three codes I need to execute, and then I can exit. Okay, fine. Now as part of the next step, we need to go to the Airflow directory, and then here I need to execute these two codes. I think the last comment had some issue. Okay, I think I copied wrong. Yeah. Now it is done. Now here I can again execute Airflow DB init just to check whether everything is perfect, and it is picking up Postgre. Yeah, initialization done. Now here we are going to create one user with name Airflow. Okay, and we need to configure the password. It will ask in the prompt. So here password, I'll give the password. Okay, password provided, user Airflow got created. Now here what I am doing, as part of the next step, we are executing mkdir command, because here all our tags will be available. And then here what we will do, we need to change airflow.cfg file. So we'll do that using WinSCP instead of doing via terminal directly. Okay. So here this is our public IP. I'll copy that. New site, host name is this. Ubuntu is the username. And for authentication, I will choose the key pair file. So here it is connected. Now I will go to Airflow folder, and here we are having airflow.cfg. I'll open this one. I need to change two things. Number one is DAG folder. So in our case, the DAGs folder is this one. So I will just put that here. And the second point is, I don't want to load unnecessarily the example DAGs. So here that one also I will change. Load examples false. I'll save this one. Okay. So this is done. So here it is completing. It is processed. Now here what I will do, as part of the next step, here if you see, I can execute Airflow DB init again. So initialization done, and then I can start the web server. But before starting the web server, let me move this hello world.py, this Airflow code, in our DAGs folder. Okay. So here I will go to DAGs, and then here if you observe hello world.py, I basically saved in F drive. Okay. And here if you observe in WinSCP, I have opened F drive only. So hello world.py, I will just simply drag and drop here. Okay. And now here I am good to start our Airflow server. It is Airflow F server is the command. Okay. I'll execute that. So here Airflow F server is started. I will duplicate this particular session and log in as Ubuntu. Okay. And then here I will execute source venv activate, and then here I need to execute Airflow scheduler. Okay. So Airflow scheduler command is also started. So I should be able to access the Airflow. I'll just copy the EC2 public IP. I'll paste that, and then colon 8080, because Airflow runs in port 8080. Okay. So here if you observe, it is taking me to the Airflow sign-in page, and here the user ID is Airflow and password is admin@123, whatever I have provided. I will sign in, and here it is showing our tags. Okay, Snowflake automation tag. Click on that tag. Here you will be able to see in graph view the tag what just now we have went through. Create EMR cluster, then ingest layer, then poll step, transform layer, then again a poll step, then terminate cluster, then Snowflake load. We need to basically create a Snowflake connection for Snowflake load first. So here I will open connections in a new tab, and the Snowflake connections what we are going to create is here if you observe in the Airflow code. the Snowflake connection name is Snowflake Con. So with this name only we will create that. So add connections, connection ID Snowflake Con, and here we want to create for Snowflake host name. So for our Snowflake account, this is basically the unique account ID dot, here this is basically our region, then dot Snowflake computing.com. Right, and then here you can cross verify also that whether this URL is correct or not. Just let me go through this particular URL, and here you will see that it is taking to our web page only. Okay, right, so that is fine. Now here schema, we are going to use public schema. Now login, Airflow will log in with login ID password, so here I'll put that. Okay, now account, our account is this much part, I'll paste that. Warehouse is compute underscore wh, database name is Lamu, or what we are going to use at this database we are going to use S3 to Snowflake. Okay, so let me just execute this command. So first we are dropping a database if it exists, we are using account admin role, we are creating this database and using this database. Okay, and then here what we are doing, here if you observe our flow, that curated layer in this particular S3 location, we will point our Snowflake external stage. Okay, so here in the transformation, curated layer name is output folder. So here if you see that we are creating an external stage pointing to that output folder using user ID password based authentication. You can use IAM role based authentication, not a problem. Now here we are executing list command, and here one Parquet file format also we are creating. So Parquet file format, because our curated layer data will be in Parquet file format, right? Here if you observe this transformation layer code, we are writing the data in Parquet file format. So that's why I have created a Parquet file format, and now that particular location is empty. So if I am executing list command, I am getting no data. Okay, now here we are creating a table. Now here if you observe the transformation layer code, it will just group by based on class name and give us the count. So class name and count, only these two columns will be there in the Parquet file. So I am creating the table accordingly. Class name is a varchar column, and from the variant data type, which is basically value column, from there I am extracting the class name, and the second column will be count, that one I am extracting with file format part. Okay, now here if I execute select star from this particular data set, now we will get no data, and this is the command to load the data. If in this external stage data is available, then using alter refresh command we can load the data. Now this command will not execute because our Airflow will execute this command. Okay, right, we'll see whether this table is getting populated or not. Okay, fine. So now let's go back to the Airflow code. So our database in this case we are using S3 to Snowflake. Okay, let's put that, and then region we are using US is 2.aws. Okay, role we are using simple account admin. Okay, so role is account admin, right? Role, region, database, warehouse, account, password, login ID, schema, snowflakecomputing.com. Yeah, pretty much it is looking correct. I will just save this. Okay, so here our Snowflake connection is also created. Now we are ready to run our tag, but before running we need to make sure all these scripts are uploaded in proper location. So here see, in scripts folder the scripts are already uploaded, and here we are having input folder which is as of now empty, and we are not having any output folder. So once the ingestion layer code is executed, in the input folder we should see that file, what ID's dataset it will download using wget command, and using AWS S3 CP it will upload it here, and then our transformation layer code will run, which will create a output folder. Okay, right, so that's how it should work. So here what I will do, I will just simply trigger the tag, but before triggering let me open AWS EMR to show you what is going on there. So this is our EMR. Okay, right, now let's start the tag. I'll trigger the tag. Okay, so here you will see that it is basically gray color means it is queued. Okay, then here if you observe create EMR cluster is executed, then ingestion layer code is also step is also submitted, and now it is in polling layer. Okay, here it is running step. So let's go back to EMR. We have not seen earlier any running cluster, but let's refresh. Here you will observe one cluster is starting. Click on that and here you will see with all the necessary details it's started. Okay, if you go to steps, here this is our step which is submitted US East 1 script runner jar file and it will run ingest.sh. Okay, right? So this is in starting state. We need to wait little bit till the EMR become waiting state and then this step will start running. Currently it is in pending state, right? So if you go to your Airflow poll step layer code and if you check logs, here it will print that the step status is currently pending like that. Okay, see here this is the cluster ID, this is the EMR step ID. You can tally here. If I copy the cluster ID and if I go back to EMR, in the summary, if I just do a search, here see ID is matching. Okay, right? That means XComs are doing their activity. Step ID, if you want to double check, copy the step ID, go to steps and you can paste it. See, step ID also exactly matching. Okay, right? Now what it is showing, the step is in pending state. And here as per our this particular code, poll layer code, if you observe here wait step to be completed, here with each 40 seconds we are polling, right? So here you will see that pending, let me change the time zone to IST. Here see at 8 PM 7 minute 34 second it polled and it was showing pending. Now it is showing after 40 seconds. Okay, 34 plus 40, it is nearly 14. Okay, there it is showing the step is pending. Then again 14 plus 40 which is 54. Then again it is showing pending like that. With each 40-second interval, it will continuously poll and show the status. Once the status is complete for this particular step, then only it will submit the next step which is transformation. Okay, because it does not mean to put a transformation step now if our ingestion layer itself fails, right? So this is how it will work. We need to wait little bit. So I will come back again once our step is in running stage. Okay. So now see the status got changed to running. Let me just refresh. Here see the first step got completed. First step completed means in the input folder we should able to see the data came. Yeah, hello world.csv came. Let us see our Airflow status. So I will go to graph view and here if you observe currently here transform layer step is submitted and the second poll is running. Okay, fine. So here see the second step it also got submitted. And here it is a command line jar and here it is executing spark submit command deploy mode cluster and here transform.py which is already uploaded in scripts folder, right? That one it will run. So as of now here if you observe no output folder is there, and if our this particular step runs successfully, what will happen? One output folder will be created and then from there in Snowflake the data will be ingested, which as of now is showing empty. Here if I execute select star, currently it is empty because it is pointing to a location where data itself is not there. So let's see that whether our this step get completed or not. So it is currently in running state. Okay, and here if you see our poll step layer, this is continuously polling. If you go to logs, here you will able to see that. Here see it is first showing pending and then it is running. Once it is completed, it will show you that the step is complete and then the polling will be stopped. It will go to the next step which is terminating that EMR cluster. Okay, like that it will actively work. So still poll step is running. Let's see. So see here our second step also got completed. Let's check. So here if I refresh, now output folder got created. If you check here the Parquet file is written. Check the timestamp, it is 8:25 PM. Currently it is 8:26 PM, right? So just now it got created. In Parquet the data got written. So now what is the next step should happen? This particular cluster we don't need now. So the cluster should be terminated automatically. Let's see. If we refresh, here you will observe that it is terminating because our this particular terminate EMR cluster got executed. Let me refresh this and here you will see that terminate EMR cluster got executed. And then Snowflake load command is also executed successfully. That's why it is showing green color. So let's go to Snowflake and check. Now I will execute select star here and see here it is beautifully showing that three different class. IDs Elosa is having 50 count, IDs Varchinica is having 50 count, and IDs Farsicolor is having 50 count. Okay, and that we know that in our IDs dataset for three different class we have 50, 50, 50 count only. So this is how you can build beautiful pipeline using Airflow, PySpark, and AWS EMR. Just launch the cluster when you need it from Airflow, then execute different steps. All for step. Once the step is completed, go to the next step. Like that, after execution of multiple steps, terminate that cluster. That way, using Transient Cluster, you can save the cost also, because your EMR cluster is running only for that much time when your codes are getting executed. Okay, so this is basically our ingest layer, then this is our transform layer, and this is the load layer where we are loading the data from data lake to cloud data warehouse, which is in this case Snowflake, right? So I hope you understood this particular complete flow and implementation from scratch. The complete code and all the resources I'll be providing in the description box or in the comment section, so that you can also implement parallelly and play with it. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.